Hi everyone. I hope you had a nice ISPCS so far. I'm going to talk a little bit about NetTimeLogic for those who don't know us, and for those who already know us, which I hope it's just a little refresher what we do and who we are. All right. So who we are kind of a startup still. Even though we were founded in 2015, we're based in Zurich, Switzerland, and we're currently 3 employees, 2 FPGA firmware and embedded software engineers, and somebody that's doing marketing and product management. And yeah, I liked really one of our customer quotes. He called us tiny but mighty, and I really like it because it's kind of true. Together, we have more than 20 years of experience in FPGA firmware and embedded software design, and we're involved in different standardization groups like IEEE 1588 or IC 62439-3. What we do, we are doing FPGA-only implementations of synchronization, network redundancy, and TSN IP cores, and everything what's kind of related to FPGA development. We're FPGA family and vendor independent, and maybe our unique selling point is that all our IP cores are designed as standalone IP cores, so you don't need a CPU, and other cores act like co-processors, so you configure them and let them run, and everything runs on its own. You can do status supervision, of course, and for that you can probably have a CPU, but you don't need to. And we have a really modular approach. So in the end, you choose which IPs you need and you can combine them as required. Besides our IP cores, we're also doing design services. So for FPGA development or for embedded software, and we're also doing some training and consulting. Just to give you a brief overview, what kind of products we have all kind of PTP products, of course, so ordinary clock, grandmaster, transfer clock, slave only, hybrid clock, timestamp units, you name it. Then our latest and greatest product is the NTP server. It's a really high performance NTP server. With a single FPGA, we can handle more than 5,000 requests, 500,000 requests per second, with a couple of watts, which is really outstanding. Then we have a couple of TOD cores for NME or UBX to connect the GPS receiver, IRIC, slave and master, pulse per second, slave and master, DCF77, real-time clock. And then we have our adjustable clock, because some clock you need to adjust, and then out of that you want to do either signal generation or you want to timestamp on that synchronized clock. Then we also have some redundancy cores for HSR, PRP, or FRER. And then we have our TSN cores, end node, and the switched end node. As I said, we're following a really modular approach. So you can take our cores and build, for example, a time bridge between different synchronization protocols. You can build your NTP server, grandmaster with it, build a multi-source synchronized clock, or yeah, just generate some timestamps and based on a synchronous clock. So yeah, as I said, I know company presentations are kind of boring. So we're focusing a little bit on the Plugfest. So in 2020, we obviously had no PTP Plugfest because there was no ISPCS. This year, we have the virtual ISPCS, and of course also no PTP Plugfest. And the PTP Plugfest was always an integral part of the ISPCS, but yeah, it couldn't take place due to the pandemic in the last 2 years. So we decided, let us bring you a mini PTP Plugfest to your home or lab. So what could we provide to you for that? So we have a PTP Reference Implementation, which can run as master or slave. So you can test your DUT, which either be a slave or a master or switch, whatever you want. It also helps you to get familiar with PTP if you're not already. Or yeah, just for fun, you have everything that you need to build a PTP Grandmaster for your home, if you like to have that. And then you really want to test the accuracy of your synchronization. So we give you that you can build a PPS analyzer, so pulse per second analyzer, to test and prove the accuracy and also do some long-term tests. And all that for the price, probably less than the flight ticket to Vienna. So you see our very first prototype here. And now you see the latest version of it, which we already also sell. So it has 8 PPS inputs, it has a PPS reference output, it has a PPS reference input, and 4 nanoseconds time step resolution on the pulse per second, on the edges of the pulse per second. You can connect to it via USB UART or via Ethernet, so it's multi-user capable in the case of Ethernet, and multi-board capable, meaning you can daisy chain them or use multiple of the PPS analyzers together to have more than those 8 PPS inputs. And it comes with a Windows GUI or a Python script just to connect to it and do your measurements. Then we have our PTP reference implementation. It supports the profiles widely used in the industry, so default power utility and 802.1as. Of course, you can choose your delay mechanism, peer-to-peer or end-to-end. It supports layer 2, IP version 4, IP version 6, 1-step or 2-step. It can act as a master or slave, and it also has those 4 nanosecond timestamp resolution. If you want to build, for example, a grandmaster, you can connect PMO GPS, or you can also connect some Mi blocks or whatever GPS receiver you want. And of course, it has a PPS output that we can measure the accuracy of the synchronization. So what do you need to build your PTP Plugfest? I'm not going through the list, but you need a couple of development boards from Digiland and NetTimeLogic PPS Analyzer Shield, which you can buy either as a do-it-yourself kit or an assembled and calibrated one. Altogether, that ends up probably with between $500 and $900 of hardware that they actually buy. And from us, you get the bit streams for the FPGA development boards and the GUIs. And yeah, you're ready to do your own tests. So this is the demo setup I'm going to show later. We have a GPS synchronized Grandmaster. We're taking the PPS from the GPS receiver as our reference PPS for the PPS analyzer. We have a PTP slave based on our reference bit stream. We have the PPS analyzer, as I already said, and we have a PTP aware switch, and we have a device under test, which is also a Digiland board, but running PTP for Linux and our implementation. So now we have here our setup and our measurements. What you see here on the left side, we have the configuration GUI of our Grandmaster. On the right side, we have the configuration GUI of our slave. Here we see the synchronization to GPS. It's really stable. It's about 10 ppm between our local oscillator and the one from GPS. Then we can see states, datasets, and so on, measure delays. So we see that it's in master, and on that side that it is in slave. And what we see on the top left is our device under test, which is a PTP for Linux implementation. It has a bit more jitter than our reference implementation, but still in the range of plus minus 100 nanoseconds. Then we have here our PPS Analyzer GUI. You see the red line, it's named DUT, so it's our PTP for Linux implementation, and we have the green line, which is the ref implementation, and the DUT master, which is the PPS of our master compared to the GPS PPS, which we use as the reference for the PPS analyzer. On the PPS analyzer screen, you can log all values, you can save the screen. It's a sliding window, so currently you see the last 100 measurements, but you can zoom out, of course. You see the initial synchronization phase here, and I just run it like for a bit more than 7 minutes.
then you can always start logging, you can stop logging, you can save the last values that you had in your screen. So this is basically the functionality that you have, and you can also set thresholds and add additional delays if you have, for example, different cable delays. I hope you find that useful and you start your own little Plugfest.
So yeah, I want to thank you. And if you're interested in creating your own little PTP Plugfest, visit our online shop for PPS Analyzer Shield and contact us for your PTP reference implementation. I know you probably didn't take notes, so that video is also going to our YouTube channel. So please visit that and get in contact with us. Thanks. Bye.